In addition to providing one-to-many face recognition for identification, face forensics also provides one-to-one. This is required to verify that the presenters of identity documents, such as electronic passports, driver's licenses, identity cards, voter registration cards, etc., are who they claim to be. Face forensics is available as an SDK to be integrated into a host application, as a standalone or networked application, and as a web service. I'm going to use the application here to show the one-to-one process, although in reality almost all one-to-one applications will use the SDK. The functionality is exactly the same. Face forensics makes the process of one-to-one matching very straightforward, even although the underlying algorithms that encode a face are complex. We'll use the screen that you see here. The interface has space for the two images to be compared side by side, with a small box at the bottom center to display the percentage match. All we have to do is drop or paste in the two images. The first step is to read the individual's facial image from the chip on the card or from the record for this individual on a server. We'll drop that image in on the left. Face forensics will encode it by analyzing some 400 features in the central area of the face, and then convert these into a unique numeric string. It's worth noting that in one-to-one matching applications, the individual is almost always compliant. In other words, they look at the camera with a neutral expression because they want the comparison to succeed. The face of the person presenting the identity document is then captured, generally directly from a camera, and dropped into the other side, where it also will be analyzed and the characteristics converted into a separate numeric string. The two strings are then compared, and the degree of comparison is shown as a match percentage. In this case, it's 98.9%. Even for the same person, this will almost always be less than 100% because of differences in the two images due to lighting, facial expression, etc. When implemented as an SDK, this percentage will be sent back to the host application, which will compare it to a threshold percentage set by the user. In practice, when the two images match above this threshold, it's unlikely that the host application will show them on screen at all. It will simply notify the officer that the identity is confirmed, and typically keep a time-stamped record of the two images, together with details of the specific location that the match took place. However, when the match percentage is below the threshold, the officer can either visually check the individual's identity or transfer the person to secondary screening. Face forensics includes the ability for an officer to magnify the two images together to help with visual verification. For example, when the officer is remote from the individual. To do this, you simply use the scroll wheel on the mouse, and both images will be magnified in a synchronized way. You can also select a particular facial feature, for example, the eye here, and synchronize and magnify both eyes together. To do this, we right-click and select Set Manually, and mark the left and right edges of the feature that we want to compare. Face forensics will then position that feature in the center of the screen, and we once again can use the mouse to magnify it. In summary, using face forensics one-to-one facial matching to confirm that an individual is who they claim to be is easy to integrate, straightforward to use, fast, non-intrusive, and also very inexpensive.